Fortress Marine Anchors, stronger, faster, lighter, presents the 2014 Chesapeake Bay Anchor Holding Power Test. Fortress has chosen Solomons, Maryland as the location for this test in the soft muds of the Chesapeake Bay. A total of 12 different anchors or anchor configurations are being tested August 5th through 8th. Chuck Hawley, a respected marine consultant and product tester, is serving as independent reviewer. The testing team includes 6 others who we will meet over the course of the week. Testing is being done aboard the research vessel Rachel Carson, a part of the fleet at the University of Maryland Research Campus in Solomons. The Rachel Carson features dynamic positioning, making it the perfect platform for this test.
We lay the test anchor out using our oceanographic winch on wire and chain. We'll take it out to the required scope, and the anchor will be set. And then quite simply, I'll put the vessel on dynamic positioning. On a calm day with no wind or current, the vessel will hold this position literally to within fractions of a meter. The mate on the back deck will then commence to try to bring the anchor into the boat. There's a tensionometer attached to the rig back there, measuring the torque in foot-pounds on the wire. The engineers use this data to compare one type of anchor to another.
High-end equipment like this tensiometer is being used to measure the holding power of the anchors, which are being dropped from the stern of the Rachel Carson. A set length of wire rode is paid out. Then the winch system pulls on the anchor for 10 minutes while the dynamic positioning system holds the boat in place. Monitors in 2 locations allow media members to see real-time graphs and data giving payout, tension load, and time of the test.
This is day 1, first pull of the day. And what we noticed is that everything seemed fine until the anchor broke free and we got essentially zero tension on the line. But we didn't show zero tension. We actually showed negative tension. So that means we have a small calibration error on the tensiometer. And it's a little difficult to do this because you have to have some known weight that you can hang and look at it. So we're actually going to hang the 44-pound anchor and roughly 32 pounds of chain. And when we do that, we're going to take a look at what the tension says and recalibrate. Next anchor today is the Manson Boss. This is a 45-pound anchor. Has a fixed shank and a rather large concave fluke. It's probably the newest anchor in the test. We got steadily increasing tension to close to 500 pounds. Then the anchor appeared to release and it never reset. It stayed at roughly 50 to 100 pounds for the rest of the test. Our next anchor is the Ultra. This is a 21 kilogram, roughly 46-pound anchor. And in this test, it's the only anchor that's made out of stainless steel. So a little different fabrication methods, and it's got a mirror finish on it. It's a very pretty anchor. So the Ultra anchor started out slowly and went to a maximum of a little over 500 pounds and exhibited a property we've seen before, which was very consistent holding between about 420 and 480 pounds. We had some motion at the end of the boat where boat wake went by, and we actually saw that affect the tension on the road. This is one of the disadvantages of using a very unstretchy road because it transmits the force to the anchor pretty quickly. So it's just something that we're learning in this testing process.
Did you know what this anchor is?
So this is one of the oldest designs in the test. This is a Danforth 35 high tensile, developed in the late 30s and early 40s by Richard Danforth and Robert Danforth Ogg. It was developed in the San Francisco Bay Area where they had oscillating tides and currents, and as a result, many of the anchors of that time would foul as the boat went over the top of the anchor. 35-pound high tensile steel anchor, and we put it in the category of a pivoting fluke anchor, meaning that once it flops over, the flukes are ready on the other side to dig in. Yeah, so in this case, the Danforth 35 high tensile slowly increased up to a maximum of about 1,000 pounds. What's interesting is that it stayed kind of in the 800-pound range for maybe 2 or 3 minutes with very, very slight variations. It came up absolutely loaded with shells and mud. I mean, it was packed, indicating that it penetrated pretty far down into the ocean bed. This is the Fortress FX37. It has two things that make it different than the other anchors. One is it's made out of high tensile aluminum, and the second is that it has two different positions where you can set it. 32-degree fluke angle for sand and hard bottoms, and a 45-degree fluke angle for soft bottoms like we've got here on the Chesapeake. So the test of the Fortress FX37 basically didn't set. We had very low holding power throughout the test. When we concluded the test and started reeling it in, it immediately dug in and held to 1,000 pounds until we popped it out of the bottom. It's really difficult to tell exactly what happened. So the next test is the Mantis 45. This is a galvanized steel anchor. It is a fixed shank anchor with a hoop on it for stabilization so it rolls upright. One distinctive feature of the Mantis is that it's bolted together, unlike the other galvanized steel anchors, which I think entirely are welded together. This is disassemblable. So if you have a cruising boat, conceivably, you could take it apart and put it below in a more compact storage, maybe in the bilge. So the Mantis had pretty consistent performance, starting at a low tension, going up to about 500 pounds, maybe as high as 600 pounds, and it stayed there for about 6 minutes of the test. You can imagine it slowly dragging, somewhat immersed. And when the anchor came up, it had relatively little mud attached to it. It came up clean. This anchor is a CQR 45 made by Simpson Lawrence in Scotland. This is, I think, the only anchor that is forged, meaning that the metal used in two different parts of it is beaten into it. It ends up having a really good strength and also ends up having a grain structure which allows it to bend without breaking. The CQR 45 is a classic plow anchor, meaning that it has a hinge in the middle, and this was thought to allow a boat to veer back and forth while anchored without upsetting the anchor. So CQR 45 had a number of sinusoidal tensions, and then it held kind of in the 300-400 pound range. It released, then engaged, held at 300 to 400 pounds for a while, released, and then it never really engaged again. So we were trying to figure out why it would go from doing a reasonably good job to having, say, 130 pounds of tension on it, which we think is just dragging on the bottom. And it's conceivable that it actually inverted in the bottom because this bottom is so soft. It's possible the anchor was upside down. Now, this is where it would be great to have a scuba diver, but I think it's a theory that we might want to follow up in a future test. This is the second test of the FX37, the Fortress aluminum anchor. In this case, we've set the fluke angle to be 32 degrees, which would normally be optimum for sand bottoms and harder bottoms, but we're going to try it in this soft mud on the Chesapeake. So the Fortress FX37 had about 4 little bumps initially in the first, say, 10 or 20 feet. Then it held up to a maximum of, say, 700 or 800 pounds, held that tension for a long period of time, and then went down to zero. After it went down to zero, it failed to reset. We actually got some fairly low readings for the rest of the test. When we pulled the anchor up, it was caked with this very thick, heavy mud right in the crown area, and it's pretty evident that the anchor had dragged and it was not going to reset. It was dragging upside down.
Were there oyster shells in it this time?
There are both oyster shells and compacted mud in the crown, where the crown and the shank intersect. So our next anchor is the Delta Fast Set Anchor. This is the second anchor by the Simpson Lawrence Company. This was a relatively modern anchor when it came out in the 1980s. And instead of having a hinge like the CQR, the engineers at Simpson Lawrence figured out how to make it so that it would be both stable, but without a hinge. It's made out of very strong steel, and it has a lot of its weight concentrated in the tip or the toe of the plowshare so that it penetrates quickly. Very popular with cruisers. So the Delta 44 was pretty disappointing on day one. We deployed it as usual. It showed some tension maybe to 150 or maybe 200 pounds, and then it flatlined from there out with tensions around 120 pounds. Really never set solidly.
A number of media members are on hand for today's testing, including Terry Borum of All at Sea Southeast magazine.
I find it very fascinating because we, as a sailor, we like our own anchor. So it's very interesting that we're seeing all the different anchors and how our anchor ranks against the different anchors that we're testing. Quite honestly, it took me a while to understand what was going on, but now that I do, I find it very fascinating, and now I can follow exactly where it's holding, where it's letting go. It's going to be interesting over the course of 6 throws what's going to happen with each anchor.
Our next anchor is a 20-kilogram Rockna, roughly 44 pounds. This is an anchor that comes to us from New Zealand. It is a fixed shank scoop style anchor similar to several of the other ones, and it uses a hoop for stability. So if the anchor inverts, the hoop should roll it back upright. So the Rockna 44 was a steadily increasing anchor. Started out, in the 100-pound range, went up to about 400, dipped down slightly, and then finished with a strong 960 pounds of tension. When we brought the anchor to the surface, it had some sort of piece of pipe or something that was across the fluke, which fell into the water before we could retrieve it. So you never know what you're going to find in the seabed. Our next anchor is the Manson Supreme. This is by the same Manson that makes the Boss anchor that we tested earlier. This is a 45-pound anchor made out of high-strength steel. It's got a single fluke on the bottom of it, a roll bar, and a single shank. Manson Supreme has one interesting feature that a couple of these other anchors have, which is that it has a slotted shank. So if you're in an area that is prone to losing anchors, you can actually attach the shackle to this slot, and it allows you to pull the anchor up backwards if you have to. Just tested the Manson Supreme. Manson Supreme had a linear performance up to about the 6-minute mark, where it reached a high point of around 750 pounds, and then it fell off sharply and failed to reset after that. It had a couple of bumps along the bottom, but really never held any substantial amount after it broke out. Our next anchor is the Spade. This is a 44-pound anchor designed by a Frenchman and built in Tunisia in northern Africa. The Spade is a galvanized anchor. It's fabricated out of a variety of pieces of steel that are welded together. And one of the interesting things is that it actually has lead that's poured into the tip of the anchor spade, and it has a fabricated shank, and the idea is to reduce the weight that's not part of the holding power and increase the ballasting at the tip of the anchor. So we just tested the Spade, and we had good performance out of it. We started out with a series of dips. When the Spade dug in, it went right up to about 400 pounds and stayed there for several minutes. Then it climbed up to a maximum of about 750 pounds, declined back down to about 400, and finished the test. At no time did the Spade break out of the bottom. So on day 1, the second pull with the Claw 44 was very interesting. I'd say on average we had about 500 pounds of tension, but we had peaks tensions of over 1,000 pounds for very short periods of time. When we weighed the anchor, it came up with a piece of cable or something across it, which may have influenced how much it was holding. It's really hard to say.
Several other anchors also got a second test today. Those will be summarized on a later report when we wrap up the week's events. For now, Chuck will tell us about another Fortress FX37 test.
For the second test of the Fortress FX37, set to the 45-degree mud angle, we had some very, very positive results. Over the course of the first 6 minutes or so, the anchor continually increased its tension until it hit a peak of somewhere around 2,300 pounds. Unfortunately, when it hit this peak, 2 things happened. One is that we blew the breaker on the winch, which required stop the winch and basically stops the test. The second thing is we believe that the dynamic positioning system somehow may have gotten a little bit out of kilter. And so in any case, we stopped the test at that point. We have additional data, but it's really hard to interpret because of that. In addition, though, when we pulled up the anchor, it had the first 15 feet of chain were massively embedded with mud, and the anchor brought up probably another 20 pounds of mud and shells with it. On the first day of the Fortress soft mud anchor test on Chesapeake Bay, we ended up doing a total of 19 pulls. So we have 12 different combinations of anchors, so we were able to do the original 12 anchors and 7 repeat. What was interesting is that at noon, after completing 8 pulls, we moved to a new location after lunch. That new location, I think the facts will show, was a better location for most of the anchors. Most of them exceeded their morning's values, where we had 2 different values. So in general, not surprisingly, where you anchor is really important, as well as what kind of anchor you use. Tomorrow we'll complete the second test of each of the anchors and try to complete a third test of each of the anchors, and then we'll have a much better idea of which anchor works best under these conditions.